We'll start in 1 minute. Today we'll start section 7.1 on the domain of a rational expression. We first begin with a definition of a rational number. A rational number can be written in the form P over Q, where P and Q are integers and Q does not equal 0. So the term rational number itself sort of indicates what we're dealing with. A rational number is the ratio of two integers, but the denominator of a fraction or a rational number cannot be 0. Okay, so here's a question. Why can't the denominator be 0? So what's the answer?
Because if you divide by 0, it's just 0.
Dividing by 0 in mathematics, it's said to be undefined, but in a very practical way, dividing by 0 just doesn't make sense. So whenever you have a ratio of two numbers, what we're doing is we're dividing the number in the numerator by the number in the denominator. But division by 0 is undefined. Division by 0 is undefined. And just in everyday common sense, dividing by 0 doesn't make sense. We can talk about that later if you want. But for now, examples of rational numbers. 2 over 3, or 2/3, both the numerator and denominator are integers. -7/4 is an example of a rational number. Terminating decimals are rational numbers. Like an informal way to read this one is 0.45. But why is this particular decimal number considered a rational number? The definition of a rational number is that it can be written in the form P over Q, where P and Q are integers and Q is non-zero. But 0.45 doesn't look like a ratio of two integers.
Because it translates into a fraction.
Yeah, it can be written as a ratio of two integers. 0.45 the formal way to read 0.45 is 45 hundredths. So we can write it as 45 divided by 100. And then if you want to write this in lowest terms, you can write it as 9/20th. So both the numerator and denominator are integers. Another example of a rational number is a repeating decimal. So here's an example, 0.1, and the digit 6 repeats forever. So repeating decimals are also rational numbers. So do you know what fraction 0.166666 is equal to? 0.16 with 6 repeating. Well, it turns out that this is 1/6. So if you divide 1 by 6, you'll get a repeating decimal. Okay, the next definition, a rational expression, is an algebraic expression that can be written in the form, so there's a typo, can be written in the form p divided by q, where p and q are polynomials, and the polynomial in the denominator can never be 0. Okay, so a rational expression is the ratio of two polynomials. So I'll write that here, the ratio of two polynomials. Okay, here are some examples of rational expressions. 5 over 3x minus 4. The next one, x squared plus 5x plus 6 divided by x minus 3. Here's another one, x minus 7 over x squared plus 3x minus 10. Another example, x to the third plus 64 over x squared minus 49. And then the fifth example, x squared minus 36 over x squared plus 16. So there are infinitely many ways that we can write examples of rational expressions. But with rational expressions, we have to remember that division by 0 is undefined. So as we have discussed, fractions cannot have denominators that are equal to 0. Well, when we have algebraic expressions in denominators, then we have to be aware of what are called restricted values. Okay, so that's what we'll talk about next. So division by 0 is undefined. Fractions cannot have denominators that are equal to 0. And the same holds for rational expressions. If the variable in a rational expression is replaced by a number that makes the denominator 0, then that number is called a restricted value. So a restricted value is off limits, meaning that it cannot be used in that expression. Okay, so our next exercise is to find the restricted values of the rational expressions below. Okay, so this is the first of the rational expressions from above. Find the x value that makes the denominator 0, and that is the restricted value. So the denominator, 3x minus 4. So we can say 3x minus 4 does not equal 0. We can solve this inequality the same way that we would solve an equation. If 3x minus 4 does not equal 0, then 3x does not equal 4. All we did was add 4 to both sides. And then divide both sides by 3. We're saying that for this rational expression, x is not permitted to be 4/3. Okay. So the restricted value is 4/3. Okay, that's all there is to it. What's the restricted value of the next rational expression? This one, x squared plus 5x plus 6 divided by x minus 3. Well, the denominator is x minus 3, so x minus 3 is not permitted to be 0, which means x is not permitted to be 3. So the restricted value is 3. Okay, the next one's a little more involved. X minus 7 over x squared plus 3x minus 10. So take 10 or 15 seconds and find the restricted values for this rational expression. So what did you come up with for the restricted values of x minus 7 divided by x squared plus 3x minus 10? Well, I'll show you. So in answer to the question on YouTube, a numerator can be 0 because 0 is a number. So for example, 0 divided by 7 is still 0. That is a perfectly fine number. The restriction is that the denominator can't be 0. Okay, so when we're finding the restricted values, we're focused on the denominator. The denominator cannot be 0. X squared plus 3x minus 10 is not permitted to be 0 because division by 0 is undefined. We can solve this inequality the same way that we would solve an equation. which is by factoring. We want one side to be 0 and find the factors of the left-hand side. Okay, it doesn't take too long to find that the factors of x squared plus 3x minus 10 are x plus 5 and x minus 2. Okay, so the product x plus 5 times x minus 2 does not equal 0. If the product of two numbers does not equal 0, then that means neither of the two numbers can be 0. So if x plus 5 times x minus 2 does not equal 0, then x plus 5 does not equal 0, and x minus 2 does not equal 0. So for this rational expression, x is not permitted to be -5, and x is not permitted to be 2. Or you can just say -5 and 2 are the restricted values. Okay, let's move on to the next row of examples. Find the restricted values of this rational expression, x squared minus 36 divided by x squared plus 16. Okay, I'll give you 20 or 30 seconds to find the restricted values. Okay, what did you come up with for the restricted values of x squared minus 36 over x squared plus 16?
X cannot be -4.
-4? Well, let's test it. If you replace x with -4, does the denominator become 0? If you replace x in the denominator with -4, the number -4 squared is positive 16, and 16 plus 16 is 32. So -4 is not a restricted value. -4 is a value that you can use in this algebraic expression. How much? Just 4. Okay, let's test it. If you replace x in the denominator with 4, does the denominator become 0? No. 4 squared is 16, and 16 plus 16 is 32. So -4 is not a restricted value, and +4 is not a restricted value. Okay, this rational expression does not have any real numbers that are restricted values. Every real number that you replace x with will make the denominator non-zero. So we would say this this rational expression has no real valued restrictions. It has restrictions that are not real numbers, but for now, we're not going to worry about what those non-real numbers are. We're just interested in knowing that it doesn't have any real valued restrictions. Okay, the next one, x to the third plus 64 divided by x squared minus 49. Find the restricted values for that rational expression. Okay, I got one answer online. The number -7, that is restricted. Is there any other? And +7. Yeah, 7 and -7 are the two restricted values. So a systematic way of finding them is take the denominator, x squared minus 49, and we say, well, x squared minus 49 cannot be equal to 0. Well, this symbol simply does not equal. So I'm throwing in some additional emphasizers, but anyway, we can solve this inequality by factoring. One side is 0, the other side is a difference of two squares. The two factors are x minus 7 and x plus 7. If the product of two numbers does not equal 0, then neither of the numbers can be 0. So if x minus 7 times x plus 7 does not equal 0, then x minus 7 does not equal 0 and x plus 7 does not equal 0. If x minus 7 does not equal 0, then x does not equal 7. If x plus 7 does not equal 0, then x does not equal -7. So we would say that +7 and -7 are the restricted values for this rational expression. Okay, the next one, find the restricted values of 10w minus 5 divided by 2w to the second plus 11w plus 5. For this rational expression, if there are any real numbers that you can replace w with that makes the denominator 0, then those numbers are restricted values. If we want to find the restricted values, we focus on the denominator. The denominator is 2w to the second plus 11w plus 5. And we say the denominator cannot be 0, does not equal 0. Well, it's not too hard to factor this. So if we write the two binomials, then if I have 2w plus 1 times w plus 5, and we can check by multiplying that this is going to work. 2w times w is 2w to the second. 2w times 5 is 10w. And we're going to add that to 1 times w to get 11w. And then lastly, we add 1 times 5. So those are the two factors. If the product of two factors does not equal 0, then neither of the two factors can be 0. So this means 2w plus 1 does not equal 0. And it also means that w plus 5 does not equal 0. So subtract 1 and divide by 2. W cannot be equal to negative 1/2. For the other one, just subtract 5, and W does not equal negative 5. Okay, so the restricted values are negative 1/2 and negative 5. Those are the restricted values. Okay, let's try the next one. So as you can see, this is not only are we learning something new about rational expressions, but we're just reviewing factoring in the process. So in algebra, factoring is one of the more useful tools to know. Okay, this rational expression, negative 11y plus 1 divided by 30y to the second plus 25y minus 5. So how are we going to find the restricted values?
By factoring the bottom polynomials.
Yeah, we focus on the denominator. We say the denominator cannot be 0. And then we find the values that make it 0, and those are the restricted values. Okay, so we can start by writing 30y to the second plus 25y minus 5 does not equal 0. So we can proceed to solve this inequality. A not equal is just a type of inequality. We can solve this type of inequality by factoring. Notice that the greatest common factor of the terms on the left is 5. So we can divide every term on both sides by 5 just to get rid of the extra factor. It's not required, but it's going to make the arithmetic easier. So we'll divide every term on both sides of this inequality by 5. And we'll get 6y to the second plus 5y minus 1 And 0 divided by 5 is still 0. So 6y to the second plus 5y minus 1 does not equal 0. Okay, well, this turns out to be factorable. So with a little practice, well, since the third term is minus 1, what does that tell us? It tells us that one of the binomials has to have a plus sign and the other one has to have a minus sign. And something else it tells us, if it's factorable with integer coefficients, since the constant is minus 1, then this has to be plus 1 and minus 1. So now we just have to figure out what the first terms of each of the two binomials is. So it looks like if I put y here and 6y there, we can test it. Y times 6y is 6y to the second minus y times 1, and then plus 1 times 6y. So 1 times 6y minus 1y is 5y, and then 1 times negative 1 is negative 1. So this is the factorization that we want. But you can factor it by using the AC method. So this method that I employed here is referred to as the trial and error method. And you can do that if you can get good at that, but the AC method will be the most efficient generally. Okay, so if the product of those two factors does not equal 0, then we say that neither of the factors is 0. So y plus 1 does not equal 0. 6y minus 1 does not equal 0. And the restricted values, y does not equal negative 1. On this one, add 1 and divide by 6. Y does not equal 1/6. Hey, what about the next one? Find the restricted values of negative 3n plus 12 divided by 84n to the second plus 76n plus 16. The restricted values are the n values that make the denominator 0. So we can start by writing 84n to the second plus 76n plus 16 does not equal 0. Can you see what the greatest common factor of the terms on the left-hand side are? Or is? So 4 is a common factor. So let's divide every term on both sides of this inequality by 4. Dividing by 4, we get 21n to the second plus 19n plus 4. And 0 divided by 4 is still 0. Okay, let's use the AC method to factor. 21 times 4 is 84. Two integers that have a product of 84 and a sum of 19, or 7 and 12. 7 times 12 is 84, and 7 plus 12 is 19. So then we'll write a quadrinomial, 21n to the second plus 7n plus 12n plus 4 does not equal 0. Then factor by grouping out of the first two terms, factor out 7n, and we have 3n plus 1. The middle operator of addition comes down. Then the greatest common factor of 12n plus 4 is 4. 3n plus 1. So the factorization, 3n plus 1 times 7n plus 4 does not equal 0. Okay, one of the factors is 3n plus 1. So if we set that not equal to 0, we'll get n does not equal negative 1/3. And then the other factor, 7n plus 4, if that does not equal 0, subtract 4 and divide by 7, n does not equal negative 4/7. Okay, let's move on to the next page. So remember how to simplify fractions. So in order to simplify a fraction, we find all of the common factors that the numerator and denominator have, and then cancel them out. So 14 divided by 21, we can rewrite 14 over 21 as 2 times 7 divided by 3 times 7. And 7 divided by 7 is 1, so this simplifies to 2/3. Negative 25/15. We can rewrite this as negative 5 times 5 divided by 3 times 5. And 5 divided by 5 is 1. So this simplifies to negative 5/3. $66 divided by 110. How do we go about simplifying that?
Divide both numbers by 11.
Yeah, a common factor is 11. So 66 is 6 times 11. 110 is 10 times 11. 11 divided by 11 is 1. So we've reduced it that much. 6 divided by 10. Can it be simplified further? Yes. 6 is 2 times 3. 10 is 2 times 5. 2 divided by 2 is 1. So 3/5. Okay. Another way to, if we started at 66 over 110, the greatest common factor of the numerator and denominator is 22. But even if you don't find the greatest common factor right from the start, you can still get the end result by simplifying the next fraction. Okay, what about 5 divided by 2?
It can't be simplified anymore.
Yeah, so this is already in lowest terms. So this is already simplified. So nothing more can be done with that one. Okay, with rational expressions, to simplify rational expressions, we have to find the common denominator, or the common factors that the numerator and denominator have. So now we don't just factor the denominator, we also factor the numerator. Okay, so the numerator, x squared minus x minus 2, the two factors are x minus 2 and x plus 1. And in the denominator, x squared minus 3x plus 2, the two factors are x minus 2 and x minus 1. So even though we're going to get a cancellation of binomial factors, x minus 2 divided by x minus 2, they cancel each other out as long as x does not equal 2. The simplified rational expression is x plus 1 divided by x minus 1. But the restricted values are 2 and 1. Because we keep in mind what we started with. In the original rational expression, the denominator has x minus 2 as a factor. So 2 is a restricted value. Even though the factors x minus 2 divided by x minus 2 cancel out, we still include 2 as a restricted value because we began with 2 as a restricted value. So that is an important detail to remember. Okay, the next one, simplify this rational expression and also identify the restricted values. The numerator factors pretty nicely. One factor is x minus 5. The other factor is x plus 2. In the denominator, x squared plus x minus 2, one of the factors is x minus 1, and the other factor is x plus 2. So before simplifying that, let's identify the restricted values. What are the restricted values?
1 and negative 2.
Yeah, 1 and negative 2. Okay, but we simplify this by dividing x plus 2 by x plus 2. So the simplified rational expression is x minus 5 over x minus 1. But we include both restricted values. Okay, the next one, x minus y divided by y minus x. Well, if we keep the denominator the way it is, x minus y, and factor negative 1 out of the denominator, y minus x. So y minus x is the same as negative 1 times x minus y. Alternatively, we could have factored -1 out of the numerator, -1 times y minus x divided by y minus x. Either way is permissible. The restricted values here are any numbers. So in other words, x and y cannot be the same number at the same time. So we would just say x minus y does not equal 0. This is equivalent to saying that x cannot be y. Those are the restricted values. But then the rational expression simplifies to -1 as long as the x value is not the same as the y value. So that this accounts for infinitely many restricted values, but we can't list them all. We just say x cannot be equal to y. Okay, let's look at the next badge. So this one, 3a to the second minus 12ab plus 12b to the second divided by 6a to the second minus 24b to the second. Well, let's identify the greatest common factor of the numerator. The greatest common factor is 3, so we can factor 3 out, and we'll be left with a squared minus 4ab plus 4b to the second. And in the denominator, the greatest common factor is 6. So we get 6 times a to the second minus 4b to the second. This trinomial, a squared minus 4ab plus 4b to the second, is a perfect square trinomial. And in the denominator, a squared minus 4b squared is a difference of 2 squares. So we can factor those. In the numerator, 3 times, and then a minus 2b times a minus 2b. And in the denominator, we have a minus 2b times a plus 2b. Okay, so in lowest terms, 3 divided by 6, that reduces to 1 divided by 2. And then 1 factor of a minus 2b cancels with 1 factor of a minus 2b from the denominator. And so we'll get 1 times a minus 2b in the numerator and 2 times a plus 2b in the denominator. Okay, but the restricted values come from the denominator. So if a minus 2b does not equal 0, then we can just say a does not equal 2b. The other factor, a plus 2b, cannot be 0. So we can just say that a does not equal negative 2b. So once again, this accounts for infinitely many restricted values. And so the best we can do, since we can't list infinitely many, is to say that whatever A is, it cannot be equal to 2 times B, and nor can it be equal to negative 2 times B. Okay, we're about out of time, so the other exercises are the same. So if you know how to factor, you can work those out. And then just remember that when you're finding restricted values, it's only variable numbers that make the denominator 0 that are restricted values. Okay, so that's all for today. Go ahead and sign in for attendance.